This is the first really big moment in the build-up to launch day as the Russian Soyuz spacecraft is rolled slowly out of the vast hangar here, ready finally to take the next group of astronauts up into space. So as it started to get light here, we've just captured the moment that the Soyuz rolls past, getting closer now to the launch site. It's been slowly wending its way right across the Kazakh steppe to this point. As the sun rises, we can see it now in all its glory, if you like. There's quite a crowd that's turned up for this moment. The crew themselves never turn out for the rollout of the rocket. That's considered bad luck, but the backup crew are here, those 3 astronauts in the backup team, and also relatives of the crews too. This is an extremely emotional moment for them. For many, it's the first time they've seen the Soyuz this close up. How does it feel?
Spectacular, isn't it? Yes.
Quite an impressive sight.
Yes, very reassuring, and we've had lots of help and support from everybody. So.
And you're feeling excited or a little bit nervous?
Very excited, really. Yes.
Have you ever seen the rocket up this close before?
No, never. No, only in pictures.
And how are you feeling looking ahead to the launch itself?
Fine, thank you. Yes, very excited and looking forward to it.
And how about Tim?
Oh, he's great. We saw him last night, and he's absolutely fine. Yeah.
I think actually most crews have felt like they're really prepared for it. They sit thousands of hours in the sim, and you do all the same procedures that you would do on launch day. And so really the only delta is the actual physical sounds and motion and feelings that accompany the rocket. There's not much you can do to prepare for that. Just enjoy the ride.
So the Soyuz is finally here at the Gagarin launch pad, named, of course, after the very first man in space, and now just being manoeuvred into position, ready for Tuesday's launch. Now, the whole rocket, the whole spacecraft and the launcher is 50 meters long, but actually the section that the astronauts will sit in is inside that white section up at the top. And that's where they'll sit on Tuesday on top of 300 tons of rocket fuel and wait for the final countdown to launch.
The main rocket is the one that starts lifting it off.
You're going to see here in just starting right about now. You can see they're starting to light. You can see retracting the last little thing. And all of England counting down, all of the UK getting ready for launch. Here we go.
There's the ignition.
Lighting.
They're the main boosters.
Here we go. And Jack is
waiting for liftoff.
You're going to see these fall away as the vehicle starts to pull itself away from her.
And we have liftoff.
And Tim's away!
Big cheer. So we've got live pictures from inside the capsule, which you can see there on the split screen. So this is the live image. And you see the vibration you talked about.
You can see how hard the acceleration is by how this little floating thing is being shaken by the acceleration. Yuri is carefully looking at things. Tim Copra is writing down information. And everyone is focused on their rocket ship.
I saw there, you've seen many of these launches. You've been involved in 3 of them. But I saw you there. You're hanging. Do you really feel a personal connection, obviously, to these astronauts?
You're calmer inside than you are out. Because out here, all I can really do is wish them well and just give them the benefit of my heart. That's all I can give.
We're about 45 seconds to the booster cutoff now. So what should we be looking for here now?
So what we're going to see, it's a beautiful, clear day in Kazakhstan. So at a minute 45 or a minute 50, you're going to see those 4 outer boosters will have done their job. They'll be above the air. They'll separate and actually flip away, and then it'll separate that whole first stage. You can see them starting to burn out now.
Yeah, we can see Tim there on the left-hand side of the picture with his checklist.
On the inside,
so they're busy.
Yeah, they're just keeping track. But watch as they separate here now. You should see the little flip of the 4 boosters coming off.
Of the emergency escape system.
So we're waiting for that separation.
There they are.
The boosters going.
The spacecraft
And they're staging.
There they go.
Wow.
See the solids coming out, or the external boosters coming off?
Well, that's
So is
remarkable.
that the cover around the Soyuz itself coming off now?
Not yet. Separated and flipping away.
And we can still see here that the engines, the main stage is ignited.
That's
what we
right.
can
Now
see
it's
glowing
that
there.
central rocket burning for another few minutes as it gets them. Now that they're above the air, now they just have to get going fast enough to stay in orbit. So now it's just like a dragster with the foot to the floor, getting faster and faster.
The next thing we'll see actually will be, or we won't see it, but for them they'll see, is when the covers will come off the Soyuz capsule itself. And this is the first time that the windows are open. They get some sense of what's happening outside.
Yeah, Tim's got a window just to his right, and right now it's covered by the aerodynamic shroud. But as soon as you're above the air, you don't need that streamlining anymore. So it splits like a big clamshell. And then
There he is. There
you
he
can
is.
see out
There's
the window.
Tim Peake there. That's Major Tim
There's
Peake
Tim,
there.
these are live
There's
images.
Tim right now.
Look at that. Oh, and there's that long, the prod that you
But as
use
you
to
can
change
see,
the-
Tim is focused on what's happening inside. He's got 6 months to look out the window. So even though that's space appearing out the window, he's focused as a crew member on flying his rocket.
And we should say, just to get some sense of the power, they're already
There's a
well
thumbs
above
up.
25.
A thumbs
Oh, there's
up
there from
there
Tim Peake. He's giving us a wave.
Hey, all right.
Hello, Tim.
These pictures coming to you live from the Soyuz capsule.
I don't know if you can hear me, you're watching on television, but there was a huge cheer from all the children there when Tim gave us a wave. It's a wonderful thing, isn't it? So he looks very relaxed.
Yeah, and the load on them is getting heavier. It's as if someone is slowly pouring more and more sand on your body as the vehicle
Oh, we
accelerates.
can see the limb
harder
of the
and harder.
Earth there through the window, actually.
If you look, you can see the sky is going from light blue to dark blue to black.
Basically seeing the edge of space, I presume, here.
That's right. We define it as 100 kilometers up, and they're almost there right now. He's almost at the legal definition. He could put that in his logbook now. Been to space. That's
I am
it's
now
almost
an
there
astronaut.
right
Is
now.
he technically now an astronaut? Is there a point at which just getting up there, or what? Is there some other tradition about one
To
orbit?
become part of sort of the definition of the Association of Space Explorers, as soon as he's done one orbit of the world above 100 kilometers,
He's in.
he's there.
So we're here in about 30 seconds now to second stage separation.
Yeah, so the first rocket got him above the air, and now it's accelerating, but now he needs the other rocket to perfectly steer them so that they're going exactly towards the space station. And that separation will happen here shortly as they go from one rocket to the other.
Yeah, we should say that we expect that we lose signal from the Soyuz at various points on the way up, but there it's back again.
We get a real sense. We can see from his window, just see Earth disappearing and it going further and further into space.
And they're covering hundreds of kilometers. They're on their way to Japan right now. It's so fast, it's hard to grasp.
And also, so 4 minutes 41, I think, second stage separation, 106 miles altitude,
Yeah.
just to get some sense for the violence and speed of a rocket launch.
Think of what it's like when you get on a train, and after 9 minutes, how far. Imagine you could be hundreds of kilometers away and hundreds of kilometers up in just 9 minutes.
And they've gone from 0 to 8,233 miles per hour in the time they've been doing this.
Isn't that amazing? Yeah, it's an uncannily precise and yet unbelievable process that makes this happen.
So when do you start to relax and think the vehicle has performed as it should? We're now in space. Is it the moment you get into orbit where you can say, right, we're going to start checking the vehicle?
Well, during launch, I think you saw Tim was focused and work, and then he went, this is great, and he stuck his thumb up for a second, and then he got back to focusing. It'll be the same when they get to orbit at just under 9 minutes. They'll focus really hard for a bit, and then he'll have a chance to sort of congratulate each other and recognize that the game has begun.
In about 2.5 minutes, they'll get to microgravity, what we always call zero gravity, their first orbit. And that is the point, presumably, where they'll separate the last engine, and then Soyuz will essentially unfurl into the spaceship that we know.
Yeah, when you're all bundled up like maybe a butterfly in a cocoon right now, and as soon as the engine shut off, then we deploy the big solar arrays. The antennas come up so we can start looking for the space station. So the vehicle sort of spreads its wings and comes alive immediately after the last rocket shuts off.
I must say, I think it's a remarkable thing. We saw Alexei Leonov earlier from those days to days when you can have live television pictures from inside the capsule. And I think we've got, is there a glove coming off there? Oh no, there's just some switch.
Actually, I think we're going to go back to Dallas, I believe, in Baikonur. Dallas, how's the launch from where you were?
Oh my goodness, I tell you what, that is how to get to the office, really. I mean, it's indescribable standing here. We are so close. And I've been to a launch before, but there's no way to explain it. It feels like it's alive. It's like some kind of monster. The noise is just immense. And also the thing that really surprised me again is just the brightness of the boosters. It's just fantastic.
So it's all looking very, very good so far for Tim. He is one step closer on his journey to the International Space Station.
Yeah, we're about
We're getting pictures, still getting pictures in from around the place.
So should we see, we're about a minute to microgravity now, so a minute to when all the engines go off. Are we looking for this thing to float?
How smooth it is right now, because this is just pulled tight straight like a guitar string under the 4 Gs of acceleration that the crew is feeling.
So it's 4G at the moment?
Yeah, it gets up to about 4 or 4.5 maximum, and you can just see it, the visual reminder of where they are.
We've got about 30 seconds to engine cutoff, so should we see something on these live pictures when the engine's
Well,
cut
we
off?
may lose the picture just because of all the mechanical things happening. The antenna that sends us the signal from the rocket is probably going to get messed up right as they separate.
I think we can show you an animation of what this will look like. Obviously, we've no external shot at the moment, but we can show you. That's what it looks like at the moment. And then at some point, then that final engine,
this section here, exactly,
will stop and almost immediately detach.
That's right. And it has been steering them right to the final direction, and they're watching.
And that's gone. Where's our friend gone?
They're in weightlessness.
So we know we're in weightless because that pen or that toy which was there has now
floated up out of the field of view, and their checklists are now weightless. Their pens are floating in front of them.
So this is when all the solar panels unfurl on the Soyuz, the spacecraft.
But don't miss it. They're in space now, Brian. They've made it successfully in orbit.
Fantastic.
Oh, we should have a cheer.
Moment.
They're in
Tim Peake.
space.
Tim Peake in space, everybody. Big thumbs up from Yuri there. They've reached zero gravity. They're 137 miles up. They still need to raise themselves about another 100 miles or so to reach the orbit of the International Space Station, and that journey will take place hopefully over the next 6 hours or so.
But Tim's got his astronaut wings.
Yes.
He's got them.
That's right. He's got his astronaut wings.
Now, we will know later as the day goes on whether or not they can do this journey, as we hope, over the next 6 hours. So it's because the journey is not all over. He still has to dock with the International Space Station. And so we'll be able to find a little bit more. We also can see a little bit more of Tim and this incredible journey that he's going on.
Yeah. So we are going to be back at, what, about 7 o'clock on BBC Two, and we'll bring you live coverage of Tim's arrival on the space station. We'll hear Tim speak from space for the first time. Chris Hadfield will be back with us. Dallas will have reaction from Tim's family. We'll be joined by the first Briton in space, Helen Sharman, and we'll be exploring Tim's new home, the International Space Station.
That's all at 7 o'clock on BBC Two. But for now, from everyone here at the space station, it's been genuinely historic, and for all of us, an uplifting morning. Goodbye.
See you later.
Good afternoon and welcome to BBC News. For nearly 4 hours now, the British astronaut Tim Peake has been orbiting the Earth on board a Russian Soyuz spacecraft. But first came this. He successfully blasted off this morning at 3 minutes past 11 with 2 other crew members from Baikonur in Kazakhstan bound for the International Space Station. They're due to dock with the ISS at around 20 past 5 this evening. Our science correspondent Palab Ghosh watched the launch and sent this report.
Hi, Tim.
A momentous day for Tim Peake and an historic one for Britain.
Tim, how do you feel?
Fantastic. Really good, we're ready.
He's finally on his way to space. Tim and his crewmates are at the Cosmodrome to get ready for the launch. On the other side of the glass are his family, Tim's wife Rebecca and his sons, Thomas, who's 6, and Oliver, who's 4.
Hey guys, how you doing?
This will be the last time they'll see him before he blasts off into space. With him is his commander, cosmonaut Yuri Malenchenko, and next to him, NASA's Tim Kopra. So how does Rebecca feel right now, a few hours before the launch?
I am really happy. You know, it's been a long journey to get to this point, so we're really excited to get to this stage in the game, and I know he is, and he just looks so ready for it, so that's great.
Then a final wave goodbye before Tim and the rest of the crew get on board their Soyuz rocket. It stands on the same launch pad from which Yuri Gagarin set off to become the first man in space more than 50 years ago. On board, strapped in, and helmets on, the crew receive their oxygen through their suits in case the spacecraft depressurizes during the launch. Now, they make their final checks.
Boosters igniting, the engines firing. Ramping up to flight speed.
The main engines have now started. Very soon, Tim Peake will be on his way to the International Space Station. And there he goes!
And liftoff. Liftoff of Tim Kopra, Yuri Malenchenko, and Timothy Peake on their way to the International Space Station. So far, getting good first stage performance. The Soyuz delivering 930,000 pounds of thrust from its 4 boosters and single core engine. The first stage of the Soyuz, 68 feet in length, 24 feet in diameter. It's going to be burning liquid fuel for the first 2 minutes and 6 seconds of the flight.
On the ground, cheers and jubilation from his friends and family.
Absolutely ecstatic. I mean, that must have been the most perfect liftoff. The weather, the view, the sky, and then the condensation cloud. It was just magical.
Pitch, you're in roll nominal.
Then, 9 minutes later, Tim is in space. The astronauts are weightless. The danger from the launch is now over, as they'll be chasing the International Space Station in orbit. And then they'll dock. After which Tim Peake will begin his 5.5-month mission in space. Palab Ghosh, BBC News, at the Baikonur Cosmodrome in Kazakhstan.
Well, Tim Peake and his 2 crewmates will join 3 other astronauts on board the space station. This is Tim Peake here with the Union flag on his arm, the first astronaut in history to bear it. For the next 6 months, he'll orbit 250 miles above the Earth, working on a series of experiments on the effects of weightlessness, as Claire Marshall now explains.
The International Space Station is a symbol of international cooperation, divorced from disagreements on Earth. 16 countries have helped to build it. There have been people living on it continuously since the year 2000. So, in numbers, it's 240 feet wide and almost 350 feet long. That's the length of a football pitch. At around £100 billion, it's the most expensive object ever made. The pressurised internal space is the size of a jumbo jet, and it's powered by an acre of solar panels. It orbits every 90 minutes and travels at 5 miles a second.
This is the actual suit worn by the very first Brit in space, Helen Sharman. She, along with all the other astronauts, also have a seat specially moulded, it's padded, so that they're not injured when they return to Earth.
It's strange to think that it's actually quite close. 250 miles is less than London to Glasgow, but life is just a little different.
And rub it in. Again.
So this is how you wash your hair in zero gravity.
There's a great sleeping bag.
And this is a bed, or rather a sleep pod. You just hitch your sleeping bag to the wall. Astronauts seem to enjoy the sensation of weightlessness, but it can be tough on the body. They need to exercise at least 2 hours a day to stop muscle wastage. And it's hard work. At any one point, there are over 300 active experiments on board. Some say the huge cost of manned spaceflight isn't worth it, that we can achieve more with robots.
You can do more science on Earth than you can do in space with the same amount of money, but there's some science that you can't do on Earth, and there's so much more than just doing experiments. This is pushing forward the boundaries. This is international cooperation and looking for how people can survive on Earth and off the planet in the long-term future. Apart from anything else, this is putting Britain back on that map.
Today, thousands of children across the country watched the launch live. One of the main goals of this mission is to inspire and excite. Among these faces could be the astronauts of the future. Claire Marshall, BBC News in the Science Museum.
And she's there now live and looking as ever, Claire, out of this world.
Thank you. Thank you. What kind of introduction is that? I have to say, here at the Science Museum, you get a real sense of the history of this, from 50 years ago with Yuri Gagarin to this, an exact replica of the lunar module that landed on the moon back in 1969. And this is our friend Tim Peake, who's now obviously on his way there. So with me to talk about the point of it all is astronomer Marek Kukula. Thank you so much for coming here today. What's the point in putting a man on the moon? You at the Royal Observatory can see so much more with your telescopes.
It's true that telescopes and also robot space probes can do amazing things, but I think there is something special when you see a human being up there. And I know I was really excited this morning to see Tim being launched into orbit. So yeah, it's about getting human beings into space.
Even though the observatory could get a lot more cash if we weren't spending it all on putting Tim Peake on.
Well, I think there are different reasons for doing different things. To study the way human physiology changes under those very strange environmental conditions that you have, weightlessness, floating around, the radiation conditions in space. So there are medical reasons, but also there are technological reasons. You can do things with people up there that you can't really do with robots. So I think it's still worth doing.
What most excites you at the moment? We haven't been to the moon since 1972. Should it be that the aim of Tim and the others is to look towards Mars, or what should be the point of their mission in your view? What would be the most useful thing for them to learn?
There is a big debate at the moment about where do we go from here. For the last almost 50 years, human beings have only been in low Earth orbit rather than further away. But I think there are now plans to go back to the moon, perhaps to have a permanent presence on the moon, and then to go to Mars. And I was thinking this morning, seeing all of those children here in the Science Museum getting so excited about Tim's mission, one of them could be the first human being to step on Mars, and it could be Tim's mission that inspires them to do it. And I think that's really the reason why we do this. It's about that inspiration, that urge to go out there and explore.
In terms of all the science that's being done on board the International Space Station, in your view, what's the most important? What teaches us the most?
Well, there are all sorts of things that you can only do when you're up there in space. I mentioned studying the way the human body responds to those very strange conditions. We learn new things about our bodies, which is medically useful. We also, by going up there, get to study the Earth, and we just had the climate talks in Paris. We couldn't understand the planet and the environmental dangers that we face without being able to go into space and study them. So there are all sorts of very useful things that we can do by going up there.
You know the stars, you know the solar systems. Yourself, would you like to go there? Are you happy here with a large telescope?
I would love to go into space if someone gave me the chance, but looking through a telescope is the next best thing. So I feel like I've been very lucky too. But I wish Tim every luck up there, and I think he's going to have an amazing time.
Okay. Marek Kukula, thank you so much indeed from the Royal Observatory. So there you have it. All of us here, Moon. Back to you in the studio.
The moon and the stars. Claire Marshall, thank you very much.
And we are very much going to stay with this story. I've been joined by Professor Andrew Coates from the Mullard Space Science Lab at UCL, University College London. Good afternoon.
Afternoon.
Is there too much excitement around all of this, or is this genuinely providing really interesting and important scientific research, this whole project.
Well, it's hard not to be caught up in the excitement today. You know, the first official British astronaut going to space after Helen Chalmer did it before, of course. And, you know, the excitement actually in the UK at the moment is how well the space sector is doing in general. You know, we're talking about industry, but also academia, our projects which are going to Mars and places, you know, just fantastic stuff. The International Space Station, though, is a very expensive thing, $100 billion, you know, large amount of money. But the relatively small amount of money which has been spent to get Tim Peake to go actually is well spent, I think, because it will help to inspire school kids. So with any you know, mission like this, it's a big high-profile thing. We're seeing somebody that people can relate to on the International Space Station. The research itself may not be cutting edge. You know, the cutting edge type of research which can be done is to do with the exploration of the solar system, the moon, and Mars, and you know, going on to Saturn and Jupiter and places like that, and of course Pluto earlier this year. These are fantastic projects, so we can't do that with this type of manned space exploration. But you know, what we can do is inspire people.
I mean, not cutting edge because. Because robots could do it more efficiently, or
I mean, generally with space exploration, robots can be much more efficient. We can reach places that other spacecraft can't reach, so we can go to, you know, Pluto, comets, currently the Rosetta comet, making some very important discoveries. The International Space Station, low Earth orbit, it's a microgravity environment. Of course, effects on the human body, that's going to be interesting if we are going to be sending people to the moon and Mars, etc., which, as an ultimate goal, is great. But the International Space Station itself, you know, has been relatively expensive for what it's actually achieved so far.
Although not much of it paid for by Britain. I mean, who writes the bulk of the cheque for that?
Yeah, well, I mean, it's been you know, America, the Russian Space Agency, European Space Agency, the Japanese Space Agency. I mean, it is a big international project with many nations involved in it, and this is one of the sort of key challenges with it. It's a big engineering project which has been put together. With very good reasons. You know, it's using technology which has been around for a while, but nevertheless it's a fantastic achievement to have been able to send somebody there and for them to be able to do some research on it.
Yes, and you talked about some of the projects you're involved with, which includes Mars, for example. Well, Marek Kukula there saying some of those fantastic children at the primary school who were watching there in West Sussex, you know, such excitement on their faces.
And that's great to see.
Is that the best element of all of this for you, the inspiration side of it?
Yes, and anybody who can inspire to go into either space or science in general, numerate disciplines. This is the type of thing that we need for Britain's future. But our projects in the next few years, so we have in 2018 a rover going to Mars. We're leading the camera system on that. So that, in a similar way, is going to be really inspiring, I think, once we actually get it launched. And again, there's a very large UK involvement both in academia and in industry on that project. So I'm really looking forward to that.
And all of that to tell us what you hope, or to learn what?
This is to look at whether there could ever have been life on Mars. And this mission actually is going to drill underneath the surface of Mars for the first time. So it's the first mission which may actually be able to tell us whether there was life on Mars. So to me, this is a fantastic project. And other projects, there's a project going to Jupiter in a few years' time, the JUICE mission, which will get to Jupiter in 2030, going to orbit around Ganymede in 2032. It's looking at Ganymede, but also Europa, which is in the Jupiter system. And then there's Enceladus in the Saturn system, which has been looked at with Cassini. These are places where life could potentially be. So we're looking really at mankind's place in the universe and whether we're alone. You know, so space science is really important in the planetary science area, but also in astrophysics as well.
Yes, very, very interesting. And we may be talking about that in years to come, months and years to come. Thank you very much, Professor Andrew Coates from University College London. Thank you very much. And a quick reminder that our science correspondent Rebecca Morell will be here at 4 o'clock, just after 4. She is going to be answering any questions you care to put to her. These text, as ever, well, there's the hashtag on Twitter, BBC Ask This, and the text 61124, 61124. So if you've got questions, Professor Andrew Coates may have just answered some of them for you, but you may well have more about all the work that's being done there on the International Space Station. That's coming up. Put your questions to Rebecca after 4 o'clock.
Now back to Earth with something of a bump, I'm afraid. We're just getting news from Los Angeles, where we're hearing every school in an area of 720 square miles has been closed, and this is because of a threat. No specific...
In Kazakhstan.
Well, it is quite a day, isn't it? And we have been asking all afternoon for you to send us questions for our science correspondent, Rebecca Morell. And I mean, goodness, so many. You and I have just been chatting about things. Let's try and rattle through as many as we can, Rebecca. Hashtag BBC Ask This, by the way. I forgot to remind you if you'd still like to send a last-minute question. A couple of the things that tie in with each other. We had an interesting thought from Jane Robinson, who says Tim Peake's seat was moulded to his body to prevent injuries on re-entry. So what happens if he gains or loses weight over the 6 months while he's there? Because that's a special thing, isn't it? And that slightly ties into another question from Robert, who texted us to say, what does spending all that time in space do to the astronaut's body? So it's a thought about the enormous potential physical changes.
How much will he change, basically, up in space?
Yes.
Well, he will change a bit, because space is generally not very good for your body. Floating about in microgravity, you lose a lot of bone density, your muscles waste a little bit because you're not really using them. So the astronauts have to work out while they're up there. They're actually tethered to treadmills and pumping weights for a couple of hours every single day, and they have a strict intake of calories too. So it doesn't mean that their body changes. Most importantly, the bone loss is the most worrying thing. But he won't change his weight so much that he either won't be able to fit into his seat or he'll fall out of it because he's so skinny. So it'll change a little bit, but he should be safe again for the landing.
Yes, one would hope there'd be various adjustments for all of that. Laurel says, what science experiments are they doing on board the International Space Station? I mean, that's one of the key elements of the whole project, isn't it?
Yeah, well, the International Space Station is essentially a giant orbiting laboratory, so they do science up there. So he will be doing things like seeing how metals melt and solidify again in microgravity. He'll be growing crystals. They take animals up in space sometimes, from ants to mice to even geckos, but actually the best kind of animal up in space to do research on is the human guinea pig. So basically he is going to be monitored. They're going to be taking saliva samples, blood samples, urine samples, I mean every kind of sample to see what's happening to
Nothing
him.
is sacred.
No, nothing is sacred. But the reason why this is important is if we have long-term space missions, say we want to go to Mars, well, you're going to be in space a long time if you go to Mars, so you want to see how that affects the body. So basically the best experiments he'll be doing up there, well, he'll just be floating around and we'll be seeing what happens to him.
And that's so interesting, isn't it? Because there are people who say the scientific, and we've interviewed some today, the scientific experiments are some of them could be done on Earth, or they could be done more effectively with robots. Why do we have to send a person up there? We could send a robot. But some of it, I think you've touched on, some of that actually only a human, I guess, can assess what this does to the human body.
And interestingly, actually, he's joining, when he actually gets into the International Space Station a bit later, he'll be joining a twin. Not his own twin, and so there's a NASA twin, and the other twin is back on Earth, and they're performing the same tests on them, an experiment and the control back on Earth to see exactly how these identical twins, you know, one who's up in space, the other one who isn't, are changing over time, which is kind of, you know, it's pretty neat experiment. They're very handy, identical twins, when it comes to this.
Was that in the job description? That's interesting, isn't it? We touched a little bit on re-entry because we had that question about the seat that's moulded to him. Charles Tilley asks, how safe is the landing when it comes back to Earth, and what is involved with that whole process?
It's not easy, actually, the landing. So they have to undock from the space station. That's quite dangerous because obviously you want to make sure the capsule is totally sealed before it moves away. Then as they come back into Earth, well, they come in with quite a bang, really. They come down in their capsule, and there are parachutes to slow them as they come back down to the Earth. And there are also thruster engines fired to slow them as they make the descent. But it's described as a bit like being hit like a truck, the impact as you whack into the ground. And that's why the seat is so moulded. That's why you want your shoulders and arms and legs not to really move. They've been told not to have their tongue between their teeth, for obvious reasons. But as they come down, they're also carried out of their seats at the end because they can't really walk after so long up in space. So they're kind of carried out like heroes almost on their seats. But I mean, it's an okay landing, but I wouldn't say it's pleasant.
No, goodness. Well, that's all 6 months away. A very, very quick thought from Lulu on Twitter. What will Tim and the crew be eating for the next 6 months?
Well, he's up for Christmas, so he'll have a bit of Christmas pudding, which is really nice. Actually, Heston Blumenthal, the chef, has designed some meals for him, and some meals to remind him a bit of the UK. So bacon sandwiches up there. He's designed something so he can have some tea-flavoured things up in space. Obviously, the key thing is nothing with any crumbs, because crumbs in space floating around are a total nightmare. So it needs to be things you can eat very, very easily. But yeah, he will get to tuck into some Christmas pudding on Christmas Day. Lucky Tim.
I don't know, lucky, extraordinary, but I don't know about lucky. Thank you very much indeed, Rebecca. Thank you. Very, very busy day. Thank you, Rebecca Morell there. And of course, in fact, the docking due to happen at about 5:20. So more on that in our 5 o'clock news hour coming up. Right now, the time is 12 minutes before 5, and we are going to return to the story that has dominated here for the last...